Okay, for this exercise, we are gonna do it's a little bit different. Okay, so we are gonna start writing what we know. So we know that the load is, the power is 8 kilowatts. We know that the power factor is 0.8. We know that the secondary voltage is 200 volts. Okay, so they are asking us to calculate the inductance in the secondary winding. Okay, so for this we are going to need to calculate the current. So we know that the power is equals to voltage and current times cosine of the angle. So in this case, the angle is equals to cos minus 1 of 0.8. So here we have, and now we want current, we got power, we got voltage, we got this. So we know that the power is 8,000. We know that the voltage is 200. And cos of this angle is just the power factor, so 0.8. And this will give us 50 amps. Now, just for sake of completeness, we know that this angle is going to be 37 degrees. Okay, now let's think a little bit about what they're asking us. They're asking us about the e.m.f. So we have here a transformer. So the primary, we are not concerned right now. We are concerned about the secondary. So we have here the e.m.f. produced by this coil. And we know that we are going to have here some losses that are going to be real and inductive. And we here have the load. And over here we're going to have our voltage in the secondary. So they're asking us for this induced EMF. So we know that the voltage in the secondary is going to be our losses, our EMF, minus the voltage drop here in this real, the current that we just calculated, times this loss, this inductance, and we are going to have also our current that we just calculated times this one. Now, since we want the EMF, then we're going to have that is going to be the voltage plus the current that we just calculated over the sum of these two losses. Now, these losses are given to us. If we look at the test, we know that here we have the power factor angle that is 37 degrees. We know that for the real part we have 0.04 ohms, and for the imaginary, for the secondary leakage reactance is 0.8 ohms. This is a rectangular angle. So if we want R, we need to multiply this 0.04 times cosine of the angle. And if we want X, we need to multiply 0.8 times sine of the angle. And like this, we have that our where they're asking us the e.m.f, and the secondary, the induced EMF. The secondary winding is going to be where we just found out, that is our 200 volts plus the current that we just calculated times 0.04. Now cos of 37, we know that is 0.8 because that is our power factor, plus 0.08 times sine of 37, that is 0.6. And this just gives us a total of 225.6 volts. And that's how we calculate the induced EMF on the secondary. Okay. Okay, now we have this exercise that is a little bit simpler. They are telling us that we have a voltage in the primary of 200 volts. In the secondary, we have a voltage of 440 volts. We have an apparent power of 20 kilovolts amperes. Oh wait, this seems to be the same exercise. Then the top one. Oh, sorry about that. Let me put the new one here. I just don't want to copy. Okay, give me a second. Okay, I'm sorry about that. Now here there is an error. The primary is 2000 volts. The secondary is 440 volts. We have a apparent power of 20 kVA. We know that the secondary has 130 turns. Now, they're currently telling us to calculate the primary turns, and we know that we have this simple relationship for a transformer with no losses and an ideal transformer, and we have almost all the values. We have the primary is 2000 volts. We don't know the number of turns. We have 440 volts for the secondary with 130 turns. Now we just need to solve for N1. So N1 is just 130 times 2000 over 440. And this will give us a total of approximately 591 turns. And now it is asking us to secondary full load current. Okay, so we know that the apparent power is voltage and current, and we want current, so we divide the apparent over the voltage, and this is just gonna be 2000 volts, 20,000, sorry, no volts amps, over the voltage in the secondary, that is 440, and this is 45.5 amperes. So I think after the other exercise, this just is simpler.